again in the class of water resource engineering. So we are learning the spillway. So today we are going to see the gates of the spillway. I am Mr. S. Sogule, Assistant Professor, Civil Engineering Department. So spillway gates. First type of spillway gates are the flashboards, stop logs, or needles. Then second is the radial gates. Third is the drum gates. Fourth is the vertical lift gates. Fifth is the bear trap gates, and sixth is the rolling gates. So we'll see these gates one by one. First, flashboards. So generally these are called as the drop-in shutters or the permanent flashboard. So here you can see these are the flashboards, and these are kind of like a shutter. We can drop this thing. So they consist of the wooden panel, usually 1 to 1.25 meter high. They are hinged at the bottom, like here you can see, and are supported against the water pressure by this strut. By this strut. The shutter fall flat on the crust when the downstream support struts are tripped. Hence, they are not suitable for the curved crust. These shutters can be raised or lower from the overhead cableway or a bridge. Various types of shutters which drop and hoist themselves automatically have been designed these days. These automatic shutters work on the principle of the counterweights acting against the water pressure. So you might have heard about the ball cock system in the water tanks itself. So same kind of things are there, and on basis of which these automatic shutters are working. So automatic shutters do not function well when interfered by the floating debris or the ice, etc. Sometimes temporary flashboards that which fall as soon as overtopped by the water may be used for very minor works. All kinds of flashboards do have some disadvantages and hence used only for small spillway or minor importance. Now the stop logs and needles. So here you can see stop logs and needles. So these stop logs you might have seen in the gatey wares also. Likewise we have in our region. So the stop logs consist of the wooden beams or the planks placed one upon other and spanning in the grooves between the spillway piers. They can be placed and removed either by hand or by hoisting mechanism. Considerable time may get wasted in removing them if they become jammed in the slots. Leakage between these logs is also a big problem. They are therefore used in very minor works. Needles. Needles are wooden logs kept side by side with their lower ends resting on the keyway of the spillway and upper end supported by the bridge. So this is the keyway and this is the bridge. It is very difficult to handle these needles at a time of flow and hence they are not used for any major work. They are sometimes used for the emergency bulkheads where they need not be replaced until the flow has stopped. Now, the radial gate or trainer gates. A radial gate has a curved water supporting face made of steel. A curved water face, which is in the shape of the sector of the circle, is properly braced by the steel frame work, which is pivoted on the horizontal shaft called trunnions or pins. So here you can see these are the trunnions and this is the gate. So this kind of gate you can see in the Radhanagri Dam, I think. I'm not sure, but I think I have seen this thing in Radhanagri Dam. The pins are anchored at the downstream portion of the spillway piers. The gate can thus rotate about the fixed horizontal axis. The hoisting cables are attached to the gate and lead to the winches on the hoisting platform. So here you can see the winch and this is the platform. The winches are usually motor driven, although hand driven driving is possible for smaller works or at a time of power failures. Now the drum gates. Drum gates are useful for longer spans in order of 40 meter or so. The medium height say 10 meters or so. The drum gates consists of the segment of a cylinder which may be raised above the spillway crust or may be lowered into the recess made in the top of the spillway. So this is the recess made in top of the spillway and it get rotates into it. So the USBR drum gate is completely enclosed and is hinged at a upstream end. The buoyant force due to head water pressure underneath the drum aid in its lifting. In this type of dam gate, the drum is enclosed on all three sides as well as on the ends, thus forming the watertight vessel. Which the drum is lowered, it fits into the recess in such a way that surface becomes coincident with the designed ogee shape of the crust. Other type of the drum gate may have no bottom plates and shall be raised only by buoyant action of the water entering into the recess underneath the skin plate of drum. The drum gates required large recess and hence are not suitable for the smaller spillway. So here you can see this is the recess when water get enter into this thing. So obviously that get lifted and due to buoyancy. Now the vertical lift gates or rectangular gates or the sometimes called as a stony gates. These are the rectangular gates opening horizontally between the grooves made in the supporting spillway piers. The grooves are generally lined with rolled steel channel sections of appropriate size so as to provide smooth bearing surface having sufficient bearing strength and are known as groove gates. These rectangular gates move between the groove guides and can be raised or lowered by hoisting mechanism at the top. The gates are often made of steel, although they may be of concrete or wood, generally kept vertical, although they may kept slightly inclined on the downstream. Because of the hydrostatic pressure caused by the upstream water standing against gate, the large friction is developed between the gate and the downstream grooves guides. Hence, if the gate is in the direct contact with the guides, it is called as there is a in a sliding gate, a large friction will be developed and it will be very difficult to move this gate. Hence, in a sliding gate, rela- relatively larger hoisting capacity is required to operate the gate because of the sliding friction has become or has to overcome. The sliding gates are therefore seldom used. The friction problem can be solved by placing cylindrical rollers between the bearing surface of the gate and the guiding grooves. A train of rollers or wheels is therefore generally placed between gate and the downstream guide. So here you can see these are the rollers has been kept between these uh, grooves so as to sliding friction gets lesser or it is much smaller. These rollers may be placed independent of the gate and the guide, thus eliminating the axle friction. Such an arrangement, when the rollers are neither placed to the gate nor to the guiding grooves but rolls vertically between the two when the gate is moved, is known as a stony gate or free roller gate. The design and construction of such gate is difficult and rollers are therefore generally attached to the gate. Such an arrangement in which vertical rollers or wheels are attached to the gate and ride in track on the downstream side of the groove guide is known as the fixed wheel gate or fixed roller type gate. The rubber seals are used to seal the opening between the upstream lip plate and the sides of the pier grooves. The large vertical lift gates may be counterbalanced by the counterweight beam and loaded to the balanced self-weight of the gate. Hence, hoisting force is required only to balance the frictional resistance. This is the bear trap gate. So, why it is called as a bear trap? So, it is look like a bear trap. So, here you can see this. gate has been supported by this strut. When the strut falls, obviously gate will fall and this way of water will gets opened. So it is a kind of trap, so it is called as a bear trap gate. Now this is the rolling gate. So here you can see the gear and this assembly has been made over here. So when this gear rotates, obviously this rack will also move upward or downward side, and this drum, that is gear, will be rotated with the help of this cable. So here you can see this uh, gate will rotate on this particular crust or it will move upward in the tower. So here we can control the level of water by using this kind of rolling gates. Now here you can see these are the photographs of the gates. These are the radial gates. Here you can see these are the gates and this is connected by the pins, and here you can rotate these great gates. Same, the close photograph is here for the radial gates. So most of the times you might have heard in the news that the gates of the dam has been lifted by this much distance or feet. So this is the mechanism to lift this thing, and sometimes this vertical sliding gates also of the same kind. Only thing is they move in this direction. Also they tend to lift by this much distance and allow the discharge of the water. So this is for the today's lecture, and for today's lecture again the references are uh, the book of irrigation engineering by Skegar and the slideshare.net. Thank you.